Good morning. Thank you for letting me speak to you this morning, and thank you to Kevin for his presentation, because I think it sets us up real well for what we're all looking for in the future and what we're experiencing today. Now, I'm going to talk to you about JPL. I'm going to talk to you about some of the fun stuff we do. I'm going to do it in a text of what we've done, where we are today, and what we're doing in the future. I'm also going to interweave, because I am a CIO, I'm going to talk about IT and how we support this and what we see for the future, because it is dynamic, it is changing. You cannot say digital transformation enough, because that's really what it is. So we are breaking new frontiers at JPL. Now, it so happens those frontiers are not always on Earth. They tend to be above Earth and sometimes far, far away. So I do want to tell you, though, we are part of NASA. We're the Jet Propulsion Laboratory, and we're also part of Caltech. I'm a Caltech employee. We're called a federally funded research and development center. We are funded primarily by NASA, but we're not civil servants. And the work we do, the resources we are able to acquire in terms of human talent is quite amazing. So we do enjoy the fact that we are part of Caltech. The fact is that as being a part of Caltech, first of all, I have to tell you something. The only way I could get into Caltech was to join JPL. So, and it's a pleasure to walk around like I belong. So, but JPL has been around for quite some time, and I want to share with you not a lot about yesterday, but I want to let you know we're about to turn 80. Not me personally, but the lab is about to turn 80. And but we're like an 80-year-old startup, because the things we do tend not to be the same thing over and over again. The missions we undertake, whether it's planetary missions, earthbound missions, deep space missions, those things we do tend to be very unique, and how we do them tends to be very unique. So in some regards, we do feel like we're a startup. I'm going to share with you just a few slides on our history, and you can sort of see from the slides where we've come from, being an actual rocket company. Now, today we don't do rockets. We use rockets, but we don't do rockets, and the people of Pasadena are very grateful for that. In the old days, evidently, we had a few errors, and things would blow up. Hence, we had the suicide squad that they were called, who founded JPL, as they were going into the Arroyo in Pasadena and blowing things up. We got better at it, though, and we became part of NASA officially in when NASA became official, which was in 1958, JPL became part of NASA. So we've had a rich history, a long history of success, and so what I'd like to do is share with you a little bit of today, because I don't want to spend too much time in the past. And I want to tell you about some of our missions that we've spent and had some exciting times. Now, JPL is not in the human spaceflight program. We are in the science and exploration program. We deliver robots. Now, Kevin mentioned robots. We do think there's a real big future for robots. So we have been delivering robots to space for quite some time. We do see that continuing, and the sophistication around that has been tremendous, and it's going to keep growing. So let me share with you some of the things we have in space today. So we do have Mars Odyssey, or what we call MRO, that is flying and circulating around Mars, and we're able to follow some of our missions there. Let me see if I can bring up something that you might find very interesting. If you can see that, I don't know how well you can see that, but if there's a little blue box in the middle, we have a spacecraft going around a planet who's taking pictures of a spacecraft on that planet. How many times do you think that's been done? Well, the easy answer on that is none. So this was a first, where we're taking a picture from a different planet, taking a picture of a spacecraft on that planet. And, you know, for those like me who really love this stuff, this was a very exciting moment. It's a historic moment. And you can sort of see the level of things we get into. Now, I have to show you something exciting, and hopefully you'll find this as exciting as I do. Okay, all right. I do want to get back to that because I want to show you a very exciting moment at JPL. We also do Earth missions, and we study the planet. We do quite a bit around, we have quite a few satellites up now that are measuring water, measuring snow depths, measuring gravity, measuring the cloud formations, and measuring, taking all kinds of measurements. Now, when you think about those measurements, you're thinking about data. And when you have data like that, you bring it back to Earth, and we do processing on that data. So as a CIO, that's a very important part of this. So what we tend to do with our missions is we're looking to improve things on the planet, to know more about our planet. And when I go back to the other slide, hopefully to show you about space and other planets, what we're looking for are really signs of life on other planets and how planets formed, how they have changed over time and what they're consistent of, and are there signs of life? We look for water. On Mars, we found evidence of water, which means there could be evidence of life. Now, why do we care about things like that? Well, it turns out that if we can understand how other planets evolved, and what their history is and what we can learn about them, could we do a better job for our planet and hopefully prevent something like Mars, what happened to Mars, from occurring again? We do believe Mars was an active planet. So if that's the case, what can we learn? So the science we do at JPL, let me see if I can do this.
Things are looking good. Coming up on entry. Vehicle reports entry interface. At this time, it will begin pressurizing the propulsion system to increase the thrust of the system. It'll use that for all the maneuvering in the atmosphere we're about to do. We are standing by for guidance start of guided entry. We are beginning to feel the atmosphere as we go in here. The vehicle has just reported via tones that it has started guided entry. At this time, the vehicle is beginning to steer its way to the target. We have seen peak deceleration. It is starting its first bank reversal. It is reporting that we are seeing G's on the order of 11 to 12 Earth G's. Bank reversal 2 is starting. We are now getting telemetry from Odyssey. We should have parachute deploy around Mach 1.7. The parachute is deployed. We are decelerating. Heat shield has separated. We're found the ground. We're down to 90 meters per second at an altitude of 6.5 kilometers and descending. Standing by for backshell separation. We are in powered flight. We're at an altitude of 1 kilometer descending. Standing by for sky crane. Sky crane has started.
Signal to us, you remain strong.
Touchdown confirmed. We're safe on Mars. Time to see where our curiosity will take us.
Got thumbnails.
All right, so I don't know about you, but I get chills when I see that. And the reason that's important is, and that was 4 years ago, but the excitement around that is not just what the mission could do, but the fact that people around the world were very excited about what occurred. And it was fascinating to be there that night. It was one of the most special events I've ever been to in my life. And the fact is, the technology to do all of that could not happen without all those people who are creating that technology. So I do have to tell you, you can cut the video if you don't mind. I do want to tell you that the amount, when that spacecraft carrying Curiosity, it's a large rover about the size of a car, landed on Mars, for the last 2 days of that mission, it was all autonomous. The whole landing was autonomous. There was no corrections in flight for the last 2 days. It worked perfectly. To do that, the engineering that it takes to do that, the IT that it takes to do that, the supercomputers we had to use to model the parachute. By the way, that's no ordinary parachute to carry that payload on an atmosphere that's 1/13 of Earth. It's quite amazing. So you can't imagine the excitement and the thrill of that. We went through that. JPL has a history of doing those kinds of things. This one was a very special moment for us. And so, as you could tell, we have, we have a history of rovers. By the way, we dominate the car market on Mars. We are a disruptor on Mars. I don't know how long we can own it, but we've got it. So, you know, when you're ready to go, we have the car for you. We've created the Curiosity Uber experience. So, and we do have other little rovers up there, and Opportunity is being one of those. And that's the tracks I was trying to show earlier. And we had 2 little spacecraft, 2 little rovers that were running around. They were supposed to last 90 days. They lasted almost 10 years. One of them died a couple of years ago, and then one is still going. And I think that's a great testament to the engineering and the capability of this country and the things that we can do when we put our mind to it. And so I do want to talk a little bit more about spacecraft around Earth. And the reason I want to do that, so if you take SMAP, for example, if you see in this particular area, you know, we're going to do some wonderful things in understanding soil moisture. I don't know, for those of you who live in California, we're kind of low in water, and we need water. And so measuring what the Earth soil moisture looks like is kind of an important thing. By the way, this all comes down to Earth through, you know, our technology to bring the data in, and we process the data, we review it, and we will publish the data. It's science and open data, so we'll publish the data. But it's a fascinating, and you can sort of see the technology, so you can see the picture of it. When these things are created at JPL, you can walk in and you can see them from a gallery, and you can see how we put these things together. These are huge. These are big devices, and they get taken up in a very interesting rocket, usually in Vandenberg or at Cape. The deep space, the planetary missions tend to go off at Kennedy, and the earthbound tend to go, not necessarily all the time, but tend to go off of Vandenberg here in California. So wanted to share that with you because we collect a lot of data from that. These data sets then become part of our analytics and how we look at you know, where the Earth's climate might be changing, where we're looking for evidence of change. We're looking at how things are happening to the Earth. And having these missions that do that are quite important for the nation, quite frankly, and the world. We also do aerospace. We also look at, in our deep space, we have telescopes that look at where planets could be. We have identified, with NASA, we have identified hundreds, possibly thousands of Earth-like planets out there. So we may not be alone. And wouldn't that be exciting? To be able to see if there's other worlds out there. I don't know about you, but that gets me excited because the possibilities. And hopefully they're friendly. But at the same time, we're looking for those, and the possibilities are much more real today than what they were in the past. From an IT perspective, we're talking about terabytes of data, soon to be petabytes of data to tell us about these kind of things. And when you think about all that data, I'll get into how that changes us, quite frankly. Let me go and show you something that you might find interesting. Where we are today, we had a mission that was going to Mars that was going to do more sample collection. It was a stationary mission. One of the instruments didn't work on Earth. It failed its test, and we missed our window, launch window. So we're going to launch in 2018 to put a lander on Mars that does more discovery, more about the drill a little deeper and get more samples and send that data and do its experiments, send that data back to Earth. Mars 2020 it's an exact duplicate of the rover that we did put on Mars, Curiosity, but it's going to carry 10 other science instruments on it to do more science. And so we're learning. Now think about this. If you want to go to another planet, you want to go to Mars, you've got to know a lot about that planet. And so we're helping NASA devise how we'll eventually get humans to Mars. And having the infrastructure there, how do you get that there? And let me show you something. So this is our flying saucer, and what it's really doing, it's a large spacecraft that will be able to deliver large payloads to Mars. And so we had to create that. This is a unique technology, again, unique in terms of how it can carry that much mass with it to Mars. And so to not only test these things out, to create these things, you know, from an IT perspective, we got to do modeling, we got to do it all on supercomputers, and we got to test it in real life. We tested a lot in Hawaii, and we were able, that test there was from Hawaii. And so we see that as a large possibility of getting heavy equipment, more material, so that we can pave a path for human exploration of Mars. So I'm going to move on a little bit, because we talked about Earth, and I want to go into Europa. Europa is going to be a very exciting mission. There's an icy moon around Jupiter. Now, I said icy. What that means is water, or a form of water, and moisture. And so what we're going to do, and I'll see if I can get to.
The search for life beyond Earth begins with understanding life on our home planet. And that story, the story of life on Earth, may have begun in our oceans. And that's because, of course, if we've learned anything about life on Earth, it's that where you find the liquid water, you generally find life. So what if I told you that there is an ocean out there beyond Earth? An ocean in our solar system that has been in existence for billions of years. It's an ocean that is perhaps 10 times as deep as Earth's ocean. It's an ocean that is global and may contain 2 to 3 times the volume of all the liquid water on Earth. It's an ocean that exists beneath the icy shell of Jupiter's moon, Europa.
So when you think about that, what we're planning on doing, I don't want to get ahead of myself here, but what we're going to do is we're going to have an orbiter go around that icy moon. We're going to then have a lander land on that moon, and it's going to drill, and it's going to pick up and analyze the content of that to see what type of water we're talking about. There are those who want us to then create a submarine that will go in that water. And can you imagine what you'd look for? Can you imagine what possibilities could be? This may be a science fiction movie, But at the same time, if you think about it, it could be quite creative, that's the type of stuff that gets scientists very excited around the world. Why is all this important to you? What do you care about this stuff? The technology it goes to develop these things, to do science, to collect science data, is quite remarkable. It's technology that we use in a lot of cases. Technology has to be specialized, but also think about the computational. We fly. These spacecraft I'm talking about, they're flying computers. They're flying mainframes of the past. And they're going to do much more processing there and send much more valuable data to Earth through our deep space network. So if you think about that, it's pretty exciting that we have to develop the technologies. When these technologies get developed, they also spin off into other more realistic things for Earth. If you think about GPS, you think about microwave, you think about some of the things of the past, that all came from a space program and how you had to be very innovative to create these kind of things. Now, I want to tell you one more, and this is up now. This is, it's not fully funded, but it's a possibility, and if it is, it intrigues me. And this one is flying to an asteroid, landing on the asteroid and picking up a boulder off the asteroid, bringing it to the lunar orbit, and then have astronauts analyze it in the lunar orbit. I'm in Hollywood, if you think about it. I mean, that's the thing movies are made of, right? And if you think about that, what an exciting mission. And we do hope that that is able to go forward. Very exciting. Now, let me tell you about the workforce at JPL. I find that to be extremely exciting. The workforce at JPL are going, yeah, that's interesting. What we really care about is the solar electronic propulsion to get us there. And why they care about the solar electronic propulsion is so that they can get to other planets like Mars and even further out with this newer propulsion to get us there. So our excitement's sometimes as much as I like to get excited about it. It's amazing to watch our folks get excited about these things, but they're really interested in the solar electronic propulsion. So we do look at planets from all over, as I mentioned before, and you can see our solar system in the midst of other solar systems. We're not so big, are we? We're kind of tiny. So the chances of us being alone, in my mind, this is my opinion, seem strange. So what excitement does that mean? To some of you, that means more customers. The world of technology and the world of space exploration is also changing. How many of you in here have heard of CubeSats? Good. Let me tell you about CubeSats. They're very small, and they could be put into orbit, and they can collect data. They can do quite a few things at a much lower cost. So a CubeSat is about 10 square centimeters. It's a very small device, gets launched off of another satellite and dropped off, or can go to the space station or whatever. And we have several that are now planned for going around the Earth, and we have some in underway as well. And so CubeSats you may hear more about. They collect data, around the Earth. And then we're looking at how do we use that technology if we go to other planets, and we can find out using CubeSats as a cheaper method of it. Now that's innovative. That's miniaturization to a certain degree, but it's innovative because the technology allows us to create these things that will collect that data at the same kind of capabilities we've been wanting. So Kevin mentioned robotics, and we do have some exciting things in robotics. We will continue to do robotics. We do, as you saw with the landing, and you see with the rovers, we're going to have much more intelligent devices out there. We've created some robots that do some amazing things. They can climb walls. They can determine where they are and then navigate around. And if you think about being on other planets, you really don't have a roadmap. You don't really have maps on your iPhone that you can tell where to go. So we're very dependent on smart devices telling us where we're going to go in the future and how to navigate the terrain that we're on. So I wanted to share that, we're very excited about robotics. We do think that we're going to get more and more. We are into machine learning. Kevin mentioned AI. That's a big deal now. If you remember 20 years ago, we talked about AI, but it didn't really have the technology to do what it can do today. The same thing with analytics and big data that we hear about so much today. The technology has changed so much that we can now do more than we ever could do with that technology. And if you're talking to CIOs like me, we already know that. So I might give you some advice for those who are interested. If you're talking to people like me, don't tell me what I already know. Help me understand what you can apply to that to make what I know better. That will help us make better decisions in who we want to work with. Just a little bit to throw out your way. JPL on Earth. JPL does use all kinds of technology, so now I'll get a little bit more in my comfort zone. We use social media to communicate. We personify our missions. If you ever see a tweet from Curiosity, or we get from any of our missions out there, we have Facebook pages on these things, and they communicate out. Turns out the public really does like this stuff, which is great. That's what we want. We want to engage the public. We want good science, technology, engineering folks we think education is important. And so having these very smart folks come to JPL and also go to NASA, go to other places in your companies, for example, we think is an imperative. And I have to tell you from my own personal experience, we bring in 700 students every year during the summer. These 700 students, they are amazing. I bring some into IT, about 20 to 30 into IT. They present to me, and what they present, you would never, at your age, if you were their age, when you were their age, I know I couldn't have got in front of the CIO and present like they do. No fear. So I have to tell you something. Something's working right, where we're getting some very bright people out there, and quite frankly, we're benefiting from that. And we see that as something that gets us excited. So the workforce of the future is coming in now, and they're going to expect a lot of different things. Mobile apps is one of them. Kevin showed a bunch of, the future looks like with mobile apps. Who in here doesn't, I want to embarrass you, who in here doesn't carry a smartphone? 10 years ago, did you carry a smartphone? 10 years ago, did you carry a flip phone? Do you still have that flip phone? I have one. And it reminds me of why I don't want it anymore. But if you, I said this to Elizabeth, how many in here, if you have your smartphone and you leave your house and forget it at your house and you're 10 minutes out, will turn around and go get your smartphone? Be honest. Be honest. Be honest. You'll do that, right? If you left your wallet, would you turn around and go get it necessarily? But you will get your smartphone. What does that tell you about you? You're compulsive, you got a problem, go see a doctor. No, what it says is that technology has changed the way we live. And as Kevin mentioned in his excellent presentation, the transformation is only really beginning. But if you think back 10 years, and now you think 10 years out, where we are today, what a change. How many people here used cloud computing in the past, 10 years ago? Anybody use cloud computing 10 years ago? Did you know what cloud computing was? It was airplanes flying through the cloud collecting data. We were doing that. Who doesn't use cloud computing today? Okay? Everybody's doing it. Now, I am a realistic CIO. I do know that if you're using Amazon or Microsoft or many of the other cloud providers, it is a form of outsourcing, quite frankly. So there's a lot that goes with that. But at the same time, the capabilities and the capacity is seemingly unlimited, is what is required for CIOs. And it's what required to do some of the things that you see on the screen or saw on the screen earlier, that we need that capacity. What we're seeing in our future missions is petabytes a day. Now, I used to think megabytes was a big deal. Remember megabytes? Then you remember gigabytes? You carry gigabytes in your pocket. You probably don't even know it. We're talking, terabytes. You could go buy a 2 terabyte disk for $99, right? You can go now, but terabytes is so yesterday. We're into petabytes. And then what's going to happen after that with exabytes? And by the way, do you know what an exabyte is? Because that's a question. Do you know what it So what I'm saying there and what I'm trying to imply is the amount of data is growing. Do you ever throw away anything? How many people here use Gmail? Right? Come on, be honest. I know you use your company email, but use Gmail. Do you ever delete anything? Google appreciates that. But do you notice that you've learned some bad habits? You don't delete anything. When you don't delete anything, there's a lot of data that stays there. And I'm not even sure when you delete it, it really goes away. But when you think about it, our behavior is save everything. If you do that in your house, you got to move. Go buy a smart home that'll tell you what to do with your email. But it's not going to work that way. So we've learned different habits in our technology space, and that is we save everything. We don't like to delete it. Now, I delete things because it's just messy, and I don't like messy stuff. But on the other hand, there are things I need to find because I can't remember anything anymore. And what happens then is we look at search. We look at ways to find things. And if you think about the technology you use, you're going to see more and more of, I want the information, but I want it in my way, and I want it with my language, and I want it when I want it. That's where the world's going with technology. And it's not, it's here today, but it's getting there. And so mobile apps is an example of how we work. Being mobile is more of an example, whether it's on your computer or whether it's on your handheld device. We do believe that one day you'll probably have a lot of technology in you. I believe that. And therefore we can find you. And we can control you. No. The idea there is that wearables, I wear a wearable. I find it useful, but it's at the beginning. And where it comes, I think Kevin mentioned about the medical and all that. I used to be CIO at FDA, so I know a little bit about medical. And I will tell you that the amount of sensors and the things we're going to be able to do with that, I think is going to be enormous. And it all comes through this latest technology and newer technologies. So how do we support that in the future? As a CIO, I'm always looking at the future. I'm always looking at things we could do and what we need to accept. But I'm going to leave you with a couple of thoughts. And there is a dilemma. And I want you to know this because you may hear it again. You may see it. And sorry for the small font. We use cloud. We use social media, as I mentioned. There's IoT, like I mentioned. Sensors are everywhere. In your home, Kevin mentioned Wi-Fi. In your home, you probably don't know, but you're probably close to 50 connected devices in your home. You probably don't know that. But it's going to go beyond that. So our home technologies are changing. But we have to do the other thing, enable while securing. We can't secure by saying no, because people will work around you. We infuse new technologies. Innovation is the key word of the day. If you haven't used innovation today, you probably haven't had your cup of coffee. And the idea behind that is we're always going to be looking at how things disrupt and how they change your businesses. Innovative ways of doing things are upon us. IT plays a strong role in that. In our case, we're looking at how we change how we work, not necessarily what we do. Now, that may be an outcome of that, but we're looking at new ways of changing, so the CIOs has to play a role in that. Of course, massive data. Need to share science data, that's a massive thing. That's not easy to do at the scales we're talking about, but it's coming. And then keep the skills. By the way, skills are very important. Do you know that the workforce, as I mentioned earlier, the students and all coming in have software skills, sometimes a lot better than the experienced worker you may have? It's quite amazing. And we're seeing dramatic change in that. Now, what they don't have, and this is to support people like me, they don't have experience and adult supervision. So there is a role for some of us. And there's a continuous need for products and services. So what I want to tell you is technology has dramatically changed, will continue to change. It always has, it always will. Chaotic. I do want to introduce you to something. It's called chaos. Is it Do you feel like the world is kind of chaotic today? Shake of heads. Do you feel that way? How many, and from an IT perspective, how many ecosystems do you work with? And an ecosystem being, how many people use Apple? How many people use Windows? How many people use Linux? Yeah, we got a few good souls who use Linux. Linux is huge, right? We use it all over the place. How do those worlds communicate with each other? How do they interact? Is that easy? You know, when you have to know too much technology to use technology, it's not a fun thing. And I don't know about you, but there are certain people who can't work that way. And they're not going to go away anytime soon. And so think about, as Kevin mentioned, the user experience. That's what we're looking at. As CIO, I have to worry about that. And I ask you to think about this chaos and how we can make that simpler for the end user, but also think about other things that will, in our case, it's going to continue to be chaotic. It's no longer best of breed only, it's all best of breed, it's best of everything. If you think you're going to have one thing that does it, you're probably wrong, because you probably already have 5 things that do the same thing. And that's just the world we live in today. So I would ask you that partner with your, first of all of you go out and hug your CIOs because I said so. The other, because they need hugging. You don't have to do that to your CFOs. At the same time, I want to tell you that partner with IT. We see the future like you see the future. And I have to tell you something. Where we are today it's so exciting to be in IT. It's obviously exciting to be at JPL, but tomorrow's going to be even better. And if you think about that, and that's where we all should focus our energies. How do we make tomorrow better? So with that, thank you very much for the time.